So for question 2, the first part, we are going to be finding g of 8 and g prime of 8. We have a function f, and we know that g of x is equal to 3x plus this integral. So to find g of 8, we're going to plug in 8 for x. And so we know that the first part of it is going to be 24. The second part we need to find using areas under the curves. So I'm going to show you, we'll just break it down step by step. So the first part, we have a quarter circle, so we do 1/4 times pi r squared. My r is 1, and so it's going to be pi over 4. That's between 2 and 3. Between 3 and 5, I have a rectangle that has an area of 2. The next one is a little bit harder. There's a few ways to do it. You can do it by writing an integral, or if you notice that this line has a slope of -1/2, which means that this intercept is at 5.5. So what's going to happen there is I have a little triangle right here that has an area of 1/2 times my base, which is 1/2, times my height, which is 1. That's going to have an area of 1/4. Then I have so that's between 5 and 5.5. Between 5.5 and 8, I have another triangle. The base of that triangle, so it's 1/2 times my base, which is 2.5, times my height, which is 3. You can write it as -3 if you want to. If you don't write it as -3, you are going to have to make it negative in the end because it's below the x-axis. You can work it out with the calculator. You find that it's -15 over 4. So when you work this whole thing out, you get 22.5 plus pi over 4. You don't need to simplify the pi. So that's my answer for g of 8. Before I find g prime of 8, I need to find the derivative g prime of x. So derivative of 3x is 3. The derivative of that integral is going to be f of x. So when I find g prime of 8, I get 3 plus f of 8. If you look at the graph, you'll find that f of 8 is going to be equal to 0. So my answer for g prime of 8 is equal to 3. So this problem, the grading is very straightforward. You get a point if you get g of 8, and you get another point if you get g prime of 8. So this problem is a common problem when you have a graph, but they actually ask this one in a more challenging way. So to find a maximum value and also to find a minimum value, you are going to check at endpoints, and you're also going to check at your critical values. To find your critical values, you need to set g prime equal to 0. So when you do that, if you look back at what we had for g prime in the previous problem, we had 3 plus f of x. So the critical values are going to occur when f of x equals -3. So if you look at the graph, the f of x is going to hit -3 right here and right here. So that's going to occur at x equals -1 and at x equals 7. The other thing is we had endpoints. So our endpoints are going to be at x equals -4 and x equals 9. So in order to figure out where our max is going to be, what we're going to do is we're going to take all of these x values and we're going to evaluate g at those values. So unfortunately, this one is kind of a long, complicated problem. You are going to be evaluating that integral. The good thing is that once you evaluate part of the integral, you can add that to the next part. Like we already know what the integral from 2 to 8 is. We found that in part 1. So I'm not going to evaluate everything, but I will show you a little bit of stuff to get you started. For example, for g of -1, you're going to substitute in -1 for x. You get your integral from 2 to -1. For that part, you do need to rewrite that integral so that you have the -1 on the bottom. You do this by changing to subtraction. So I'm not going to show you every step with this. However, if you really want to know the steps, please send me an email and I can take a look at your work if you went wrong. I will, however, give you all of the answers for this. So g of -1 is -4 plus 9 pi over 2. G of -4 is -12 plus 9 pi over 2. So then I find that g of 7 is 21 plus pi over 4, and g of 9 is 27 plus pi over 4. Hopefully you can see that g of 9 is the biggest answer. If you don't see that right away, you can use your calculator. So you can just write, since g of 9 has the largest value, that is our maximum value. Actually, if you show all of this work, you don't need to write a sentence, but it's not a bad idea to write a sentence, especially if they say to justify your answer. But generally, finding your critical values and testing at your endpoints and your critical values is sufficient for justifying your answer. So to get full credit on this, you need to do several things. You need to mention your critical values. You need to check at your endpoints. And you actually need to get the answer of x equals 9, and you have to show work for that. So for part C, they want you to find the limit as x approaches 2 of f prime of x. So keep in mind this is the graph of f. So first thing we're going to look at is the limit as x approaches 2 from the left side. So keep in mind that this is a circle here, or at least half of a circle. At x equals 2, you have a vertical tangent line. What that means is that your derivative there is non-existent. So because the derivative there is non-existent, the limit at that point is you can either say it's infinite or that it does not exist. Same thing happens with the limit from the right side. There should be a plus there. That one also has a vertical tangent line because it's a circle, so that one also does not exist. So if you're looking for a limit at a point and at that point you have two different functions, like here we have two different partial circles, you're going to have to look at the limit from the left side and the limit from the right side. If those two things are not equal, or if they both don't exist, then the limit at that point does not exist. So for this one's only worth 1 point, and that's for saying it doesn't exist and giving a justification. So for part D, we are finding a limit as x approaches 3 of this long fraction. So first thing you're going to do whenever you have a limit is substitute that value in. I usually, if I have a fraction, I like to substitute the value in separately for the numerator and the denominator. So if you work this out, you should find that g of 6 is equal to 18 plus the integral from 2 to 6 of f of t dt. The area from 2 to 6, you can look back at the stuff that you did for part A. You will find that it is pi over 4 plus 2. And that actually gives you 0. So you can do the same thing for the limit of the denominator. You'll find that that gives you e to the 0 minus 1, which just gives me 0 also. Since this is going to give us an indeterminate form if we evaluate it by substituting, we are going to use L'Hopital's rule. So for L'Hopital's rule, we need to take the derivative of both the numerator and the denominator, and we take it separately. So for the numerator, I have my 8. The derivative of g of 2x is going to be g prime of 2x. Make sure that you use the chain rule. You have to multiply that by the derivative of 2x, which is 2. When you take the derivative there, the 2 pi and the 160 are going to cancel out. In the denominator, I am going to use the chain rule again, but the derivative of the stuff inside of the e is just going to be 1. So I would just multiply the e to the x minus 3 by 1. So in this one, I end up getting 16g prime of 6 over e to the 0. Keep in mind that e to the 0 is 1, so I get 16 times g prime of 6. I am going to find g prime of 6 using that equation that I have. Actually, the equation that I got in part A is going to help me. So in part A, I got that g prime of x was 3 plus f of x. So I'm going to get 16 times 3 plus f of 6. F of 6 is negative 1, so I get 16 times 3 minus 1, which gives me 16 times 2, and my answer there is 32. So the first thing that you needed to do to get points was you needed to check that both the numerator and the denominator were 0. That gave you an indeterminate form, which meant you use L'Hopital's rule. So that's your first point. The second point that you can get is by doing both the numerator and the denominator, doing those derivatives correctly, which should give you this part right here. The final point you get for this problem is by getting the answer of 32. So for the 2 questions that you just did, the recommended score, if you want to know how you would have done if this was your AP exam, if you got 14 and above, that's pretty good. That would be equivalent to a 5. If you got 12 or 13, that's a very small range, that would be equivalent to a 4. If you got 9 or above, which is less than half the points, that would be a passing score. So good job if you got 9 or above. If you got below 9, that's a sign that maybe there's a few topics that you need to review. That would be equivalent to a 1 or a 2. So please also write your score that you would have received based on this chart.